Hello everyone, I'm Alex and together with Livia we will host this event. I am a software tester for Centric for about 3 years and I help municipalities in the Netherlands with managing their taxes and making sure that the quality of our product is up to par with their requirements, both functional and non-functional. You probably know by now that this is delivered by Centric, but I want to tell you a few sentences about us. We are an international company present in 10 European countries. We are a Dutch company. We have more than 4,000 professionals that work on our products, but also deliver outsourced projects. We also say about ourselves that we know a thing or two about creating software products. Some of the areas where our products can be found are in the Dutch public sector, supply chain, HR and payroll, infrastructure, and XR. In Romania, Centric has an office in Iași where we do research and development, and more than 300 experts are building tools for our customers. In the Centric testing community, we have a big group of colleagues that are focused on delivering the most exigent requests for our customers. The QA discipline in Centric covers areas like education, test processes and innovation, technical guidance, and career growth. We assure the quality of web and desktop applications by various tools and technologies. We also cover the expected performance of our product and dismiss any security breaches. Now I will let Livia continue and she will tell you more about herself and the event.
I'm Livia. I've been with Centric for about 6 years now, and I'm passionate about the testing field, particularly test processes and test automation in all its forms. My colleague Alex already introduced me earlier and already told you some things about Centric, and I'm going to continue from there. Centric focuses on learning. That is a big part of its culture. So we are promoters of knowledge sharing, also from inside and outside the company. And today we have a special guest, which is Tariq King. We wish him a very warm welcome. He will be the first to start the series of 3 conferences provided by Centric. The title of his presentation will be AI for Testing Everything, an Automation Superpower. Next week, we'll dive into software development with Vladimir Korikov, and after that, the following week with Vitaly Friedman into the UI UX field. A little more background about our guest today. He is the chief scientist at Test.ai, where he leads research and development of their core platform for AI-driven testing. We've seen him 2 years ago live on stage at the local conference, and we are happy to see him again now in a slightly different setup. But even so, we are sure that we can learn a great deal from him. Something that we might not find on Google or LinkedIn about him is that he loves traveling. He managed to sleep on the wall of China and is probably the first person from Barbados to enter Moldova because they couldn't recognize his passport at the entrance in the airport. We will be together for the next 2 hours, and because we know how important is for some of you to find answers to your challenges, even if you can't speak directly with Tariq, we allocated enough time for you for a Q&A session. We will kindly ask you to put all your questions in the chat area whenever they pop your mind. And after the presentation is done, our guest will be more than happy to respond to them. I know everybody is waiting for Tariq to speak, so I won't make it any longer. So Tariq, the stage is yours.
Thank you, Livia. And again, sorry to be late. I guess everything is trying to keep me from giving this talk, but let me just go and share my screen. It's great that I'm here now and I'm ready to go. So let me just share my screen. Let me know if you guys can see the title slide. Are we good?
Yep, I can see it, yes.
Okay, great. Awesome. All right. Cool. So first, let me just say a big thank you to Centric for having me here, especially to kind of open up this series of events. As Livia mentioned, this is AI for testing everything and an automation superpower. So I'm really attached to Romania, just so that the Centric people feel special. One of my best friends is from there. I really enjoyed it, and actually a lot of this AI stuff started at Code Camp, which was my first trip to Romania, giving a keynote. So I'll kind of reflect a little bit on that and talk about the journey since then, right? And yeah, I'm sure there'll still be plenty of time for questions and engagement at the end there. So who am I to talk about AI for testing? Well, I currently lead the core platform team at test.ai, where we build a platform that uses artificial intelligence and machine learning algorithms to help us automate software testing and do different types of testing and kind of bridge the gap between manual and automated testing, right? Now, you know, I haven't done this presentation solely on our product or anything to do with even our own advances, but the space, right? Because there's a lot of folks actually pursuing this kind of dream of using AI for testing. It's a very exciting time to be in testing. But I have a track record in software quality, right? Coming from all an academic background and then moving into industry, and I've been in industry for the past 9 to 10 years, focusing on these types of problems. So we'll get more into exactly what. So I like to think of this this talk as a trip of sorts to show off the strength of AI, right, and the skill and really a tour de force of what is a new space for us, right? Testing has suffered a lot from not really being on the forefront of innovation and has always been kind of catching up to developer tools. And this is the first time that I'm seeing AI giving us the strength and the power to actually shoot in front of a lot of aspects of the developer tools. So, you know, it's a pretty exciting time. In terms of the agenda, I'll kind of review a little bit of what do I mean when I talk about AI for software testing, and then we'll take a trip, like I said, starting from the stage in Romania, now ending to the virtual world in Romania here, but we'll go through using AI to test different dimensions of software testing and address those different levels of testing, address different quality attributes like performance, and also looking at special areas and special domains that we haven't been able to automate before that we're now able to automate with AI. And then, you know, we'll wrap up and we'll have Q&A on the tour de force. All right, so some foundation. What is artificial intelligence? And, you know, I like to remind people it's this broad field of computer science where we're trying to get software to learn and reason like humans should intelligently, right? And so anything that we have that deals with that even slightly falls under the umbrella of AI because it's the broad overarching theme. When it comes to machine learning, you're now talking about the programming model. Like, how do we get these machines to do these intelligent things? And it's really about moving away from a place where we have machines following step-by-step instructions in a very imperative manner, one where we now program the machines by giving them examples, right, data, rather than these hard-coded instructions. And last but not least in this realm of things is the idea of deep learning. And deep learning is this subfield of machine learning. So it still deals with the programming model, but now we're talking about ubiquitous data, large scale neural networks with, you know, hundreds and hundreds, or if not even thousands of hidden layers, and a level of complexity that we haven't seen before. And so a lot of the advances that you've seen have been because we have data available to us, right, in combination with techniques like deep learning. So just to focus a little bit more closely on machine learning, because that's where most of these applications that you'll see me talk about in respect to software testing lie. There's a couple different forms of machine learning that we use to help us automate testing. The first one being supervised machine learning, where you're talking about giving the machine these examples, right? These examples that are very much labeled examples. So this is a cat, this is a dog. And when the machine encounters an example that it hasn't seen before, then it can make an educated guess that, you know, okay, based on what I've seen before, like, I think this is a cat, right? And it has it. And so in essence, part of machine learning is this classification problem where we can classify discrete things, but you can also apply this to being able to predict quantities like the selling price of a house or an amount or something like that. Another branch is dealing with now less about these known patterns, right, like cats and dogs and these things that we know, more about letting the machine go on just a whole pool of data where you might not know what the labels are. And the machine looks at that data based on certain features or characteristics that it finds. It tries to group similar pieces of data together through a process called clustering. And so whereas classification assigns a label to the data sample, clustering just places the data sample into a bucket with other similar samples for which you don't know the particular category or label of that data. And so in that sense, unsupervised learning is good for discovering unknown patterns, right? You actually learn from the machine because the machine is teaching you about these different patterns. And last but not least, there's the idea of reinforcement learning. And many of you would have heard about this, especially when we start thinking about games and a lot of the more recent advances where we have used AI to play Go and Atari games or even do self-driving has been because of reinforcement learning combined with deep learning. And what reinforcement learning is all about is just saying, well, let's let the machines learn by trial and error. Let's give them some goals and attach some rewards to those goals for the behaviors that we want to see them exhibit. And so, you say, I want you to jump over this thing and get as far in this game as possible. So I'll give you a reward every time you avoid an obstacle, right? Or I'll base your reward system on just getting the highest score possible. And the machine, after several iterations, it starts off pretty bad. And after several iterations, it gets better and better at doing this. And so all three of these things we have incorporated and used and leveraged for the good of software testing. And it's led us to this kind of field where we talk about leveraging AI for testing in the sense of AI-driven test automation. And that's where our tour de force is really on the different tools that we can build using AI and to help the software testing become a little less manual and needing people to do tasks and a little bit more automated from an end-to-end process. But recognize that it's just part of the puzzle, right? Using AI for testing, because at the end of the day, when it comes to the intersection of AI and software testing, we have to test AI systems. And at some point, the systems seem to learn and do strange things. And so we probably need to think about designing these systems with the ability to test themselves. And so just want to put that in the context of everything that we have going on. So this is it. This is when I was in Romania last, and ironically in Iași, and it was actually my first keynote speech that I ever gave, and I gave it in the United States first, and then I went to Code Camp and gave it there. And that goal of that keynote was to try to inspire folks to think about whether or not AI could be this power up, right? Like you see these little power pellets on the screen, and as Pac-Man eats those smaller power pellets, it does nothing for him really, at least in terms of fighting the ghost. But when you hit that big one, then all of a sudden it's a game changer. And so it was really, can AI power up our traditional test automation and give us giant gains as opposed to these small linear gains that we've been seeing before. So this is really a follow-up on where have we gone since then. And so now let's just get into these different dimensions of our tour, right? So let's look at how AI is being applied to software testing at different levels. So when I say different levels, we're talking about the user interface or the system level, the API or service level or integration level, and then the unit level. And most of the industry is actually focused on leveraging AI to build out this next generation of GUI test automation frameworks. There's several companies and startups, including Test.ai that I work for, that are trying to leverage AI for functional UI testing for web and mobile applications. So our platform, which we refer to as Carbon, allows us to do this, and it's pretty cool. But it is not really just on the level of testing these web and mobile apps anymore. That is all cool, but we've been leveraging it for other things and other aspects. Because once you start thinking about AI, you start to see that there's some benefits of using computer vision. Number one, we can now reuse a lot of our tests across application domains and even the app stores and try to test all of the apps that you can see. And then for things that, you know, your traditional Selenium doesn't help you with, things like video games, for example, that you don't have a DOM, you have to rely on visuals. They're also highly graphical and you would want to validate the look and feel of these things anyway. Then AI gives us that superpower of forms, right? And then last but not least, other specialized domains like video streaming, anything that, again, when it comes to automation frameworks, we can't really do much these days, right? And just validating at the lower levels doesn't help us with the end user experience. So, you know, AI is our superpower, and we like to view it that way, where anything with a screen can be tested. And like any kind of superpower, you tend to also think that there might be some form of kryptonite. And the kryptonite in my mind for AI, when it comes to automation and testing, is the fact that it seems to be very complex, right? It's very heavy, right? But we also have a lot of compute. And so the complexity really just falls into how well can we adapt ourselves to be able to understand and interpret and explain these things. And for me, it starts with knowledge sharing, right? You heard Centric talk about knowledge sharing as a focus. Well, this is one of the reasons that I do what I do. Number one, it's very cool, but even when it's not cool, it's just, I feel like it's a responsibility to share what we've learned along the way. And to prove to you that it's not just about being cool and flashy, I love to put this slide in here because the fact is that we've used AI to validate things like BIOS screens, right? And if you start to think about legacy software and the fact that, yeah, you know what are we going to use for automation there? Are we just going to be clicking keyboards and stuff like that? Well, that stuff is always brittle if things change, but we have run our computer vision on screens like this, being able to visualize these elements, interact with them, use OCR to translate them, and automate the entire app. So it's not just the pretty things like games and video streams and all that stuff. Sometimes it's just solving a problem that someone has, which might be a hard problem that's because of older technologies, and AI gives us a bridge there. So as part of making sure that kryptonite doesn't have any power over us, I like to walk through how this stuff works. And there's really 4 quadrants, starting in the lower left-hand corner, where you first train the bots to explore. And when I say that, the bots need to be able to perceive the environment and see what's on the screen. And then it breaks down the structure of the application and can even observe different behaviors over different builds. And so you talk about recognizing the elements just like a human would, right? Like I would see that that's the product in the middle there, or I would recognize that the shopping cart is in the upper left-hand corner. And so the bots get trained on many, many examples of shopping carts and of products and of different things, and then they can interact with them. As they do that, they build models, because we as humans build mental models all the time to deal with uncertainty. You know, we may walk into a dark room, but we have been in that room before, and we have a model still in our mind of where all the furniture is and everything is located, so we can navigate through that room without, you know, getting harmed, even in the dark. And so the bots, if they come to an application that they may have seen before and it looks similar, they can then say, okay, you know what? I don't recognize what's going on here fully because I can't see some things, but based on what I remember, let me try this, right? I remember we talked about reinforcement learning. So trying things and failing and learning from them are part of what they're good at, as opposed to traditional automation. And so it helps them to be a little bit more resilient and the automation to not fail just because something changed. So you also want to interact with the application, and I don't mean just apply inputs, but you want to be able to observe outputs and tell and detect when things are wrong. And so you train the bots as well to model the input and output type of behavior that we need in testing. And then the cool part about it is that as they go through and they try things and they learn, or they get feedback later on, or we realize as humans that we may have not provided them with enough examples, the bots get better over time. And as they get better, we start to see them do a lot more than we can do on our own, especially because we can scale these things very easily. So I can't mention AI for testing without talking about the work that Diony Santiago. Diony works with me as the engineering director over the platform team. And he's also, as in forms of a superhero, who's pursuing his PhD in the area of AI-driven automation. And so he has his master's thesis that he did in 2018, and now he's on his journey towards the PhD, working on extending that that work. But he's here using this stuff to automatically apply boundary value testing and equivalence partitioning to the pet clinic application, and using bots and scaling them up to do that kind of testing. And it's actually pretty impressive. There's actually an open source prototype out there that we just put out there as part of his PhD called Agent, where you can go and see AI generating and exploring for the purposes of testing. It's called AI generation and exploration in tests. And so that's out there for educational purposes. And Diani used some very cool models to teach the bots how to generate high-level test cases just as we would. And the cool thing is that then they can keep generating more and more tests as you train them. They don't get tired of generating tests and executing them. So if you haven't been following Diani, I encourage you to follow Diani on that journey. He's again focused on the UI level, which aligns with our mission. So then moving out of test AI and looking into the space, there's also folks looking at the API level, like how can we actually automate API tests, right? Now you're not having a user interface, we have a programming interface, but there's still inputs and outputs, right? And AI is very good at just modeling kind of any function from input to output. And so kudos to Gordon Merritt from Liberty Mutual. He has a patent out on predictive AI test generation using AI, a project that he calls Sarisha. And how this works is pretty cool, because it also aligns with something that I've been talking about all week, which is performance testing. But he used Swagger as a specification language, some specification documents in Swagger, and trained the bots how to generate inputs and determine the correctness of outputs and which tests should be prioritized. So it leverages kind of functional API specification using Swagger to help with test generation and learning. And currently there's a big gap, which is why I was so glad that I found this and met Gordon, because there's a big gap where we're not doing enough of the API level. A lot of people are doing API testing, but the AI space, AI for testing space, is not doing enough focus on, in my opinion, on leveraging AI to do API testing. There's some other companies that are doing things like that, right? Where they're saying their approach is to have the UI in place first and then record, kind of like our record and playback tools that we find in functional testing and performance testing. Let's do some recording and then we'll translate those recordings into API tests for the lower levels. There's nothing wrong with this, but the part that's missing is the learning and generating new ones, right? And usually when I pick up these tools, I'm seeing that part missing. That's why I have it here in red. And it really needs to be there. Another disadvantage is that you have to wait until the user interface is actually built to apply something like this. And it's not the worst thing in the world, but I would like to see it happening earlier on in AI for API testing and test development. Now the last level at the unit level. So there's been a lot of work. You would have seen a bunch of stuff in the area of generating code and code generation, and we'll talk about that. But here, this is specifically DiffBlue as using AI for generating unit level tests. So if you navigate over to DiffBlue's website, there's an interactive widget. This is just a GIF of the interactive widget where you can see that they're generating entire Java classes that are the full-blown tests after just analyzing some source code. And this is because there's a lot of researchers and practitioners out there just looking at AI's ability to generate text and generate text in a way that you can't necessarily even distinguish that text from a human, right? So there's these few short learners. You might have heard of the GitHub Copilot, which is on the right here, which is generating complete functions, not just IntelliSense signatures, complete functions, right? And so this is the future, and you're going to see more of this, all based on a lot of the GPT-3 work that OpenAI did, foundational work on using natural language processing and combining that with deep learning models to generate text that you wouldn't be able to tell whether or not a human did it or a machine did it. So pretty powerful to see that coming into the testing world as well. All right, so when we think about software, testing is one thing, but in general, it's more than testing, right? It's all about quality, and there's different attributes that you have to care about, right? And so this field is really picking up with a lot of different pieces intertwined in it. And once you start thinking about attributes, you start thinking about non-functional requirements. And I just spent the whole week thinking about performance, so I had to put this first. But we're seeing a lot of things happening where we can leverage AI for performance in different ways. So one of the first ways, even from our own mission standpoint, our mission is to test the world's apps, and not just one app, but all the apps. And we use a lot of the test information that we can get with AI across applications. And once you start doing that, we can test the whole domain. And as soon as we're doing functional testing, even from a UI perspective, we can start capturing metrics from the front end, which actually represents the end user's true experience. And then what we can do with that information is that we can compare those same test cases and flows and the performance metrics that are pulled out by them, not just for your app, but across other apps, and tell you now, okay, well, if you're a retail app, we just tested all the retail apps, and we tested login, we tested checkout, we tested this and that, and your app, yeah, not doing so good, you know, it's in the, you know, lower portions in terms of percentiles for certain metrics, right? CPU, response times or latencies, etc. And that's powerful stuff, because now the test information that comes out of that is actually bringing market value, right? Like, I'm now in a competitive advantage because I know that, you know, if I'm Walmart and I'm comparing myself to Amazon, and, you know, I need to do better because they have a highly performant system and I am lagging behind. So that's pretty cool to see. And so, you know, there's lots of benefits that the bots are crawling through all these apps and doing these flows and chopping up images. And, you know, we're able to run like 1,000 apps per night on a single or two machines, and then have monthly runs with 5,000 apps and do that sort of testing. And the benefits are for the person who's the owner of the app store to track health or to improve vendor relations. So there's a lot of benefits that are offshooting from applying AI across a dimension like performance, even still at the UI level. But, you know, today I had Diony Santiago come in and share about some of the advances in just using this stuff, not just to check what's going on in the UI, but to actually load up data centers in different geographical locations. And so he showed the team at Centric how we use VMs and Azure to spin up VMs in multiple geographical locations across the world and simultaneously test some game streaming application. And that's pretty powerful, right? Because you're, again, you're leveraging AI to do things that maybe you can't necessarily do end-to-end without something like AI, right? Because remember, we're talking about game streaming here. So even though we could always simulate load on the data centers, we can do all that stuff without using AI. But when this streaming application gets to you, there's no DOM, there's nothing to attach to. Like a formidable solution is using computer vision at that point, because you don't have objects, you don't have a DOM, all you have is a video stream. And so, yeah, today we walked through exactly how this works. So I know some of the folks from Centric are now experts on how we can use Azure to spin up, you know, VMs and do fully automated cloud deployments. So you're talking about full automation, not having to touch this to install all the dependencies and, you know, have security in place. And one of the major benefits here is just the return on investment in time. The bots can do this testing, execute 15,500 tests in 10 hours in parallel, replacing about 21 man days of human work. And so that is automation at scale. That is something that we can't do without leveraging this power of AI. And in the process, reproducing issues and finding bugs, all sorts of bugs, right? Failure to start the streams, stream connections lost. And one thing that is super cool about this is that the bots don't only find these issues and record the metrics and generate reports and all that stuff. They actually can file the bugs in the app. So a lot of a lot of tooling nowadays and software that we built have feedback mechanisms. And some of those feedback mechanisms are actually tied back to the development cycle. So I can go on to Google Maps, and if I find an issue, I can report it, and it goes straight back to engineering. In a similar way, a lot of these tools have, well, we love your feedback. And so our bots find issues, grab the screenshots, grab the information, and then go back into the app and submit all these issues automatically. And if that's not a superpower, I don't know what's a superpower. So last but not least, in the realm of performance, and I also had Kaushal come and visit with folks today. You know, performance testing is one of those things where there's been, quite frankly, a slow drag on some things, right? Load Runner has dominated for years on many things, and it's been a standard for end-to-end performance. And you have these very talented people sometimes doing tedious tasks and having to rescript when network patterns change or when there's a new version of a service and stuff like that. But Kaushal and his team at the Ultimate Chronos Group really went through and figured out a way to automate their regression process, right? And something that they were doing in a very traditional performance testing manner once every 4 months. Now they're doing it sometimes 3 times in the morning. He already had 3 builds this morning and 15 minutes able to update and, you know, get performance feedback and really do performance continuously throughout the life cycle. And so encourage you to check out both Kaushal and Diani and their work. All right, so continuing on quality attributes, one of the key things here, because we have computer vision, is that now the bots are able to test look and feel, things that they couldn't do before. You'll see tool vendors like Applitools talking about visual testing, and that's pretty impressive to have visual testing in place. But here you're talking about looking at the layout and the look and feel, and there's all sorts of guidelines for building, in this case, building good mobile applications, right? What are those patterns looking like? And so you can train the bots on those patterns and literally teach them, like, this is what a good layout looks like. This is an example of bad layouts. And then they can go through and they can start to check the applications as they're testing from the UI to say, like, hey, look, here you're missing a search bar, right? A little X in the search bar. That's a good pattern where you want to be able to easily clear the search bar, and you don't have it in your app. And this is actually a real production bug that we found in a major application, that guideline was being violated by looking at these human interface guidelines that iOS pulls out, or Android's design guidelines. The bots now can, again, look at this like a human would, find these issues, report them, and that avoids any kind of you know, normally when you see these guidelines, they're always ambiguous, right, and open to interpretation. But the bots just need the examples. Give me all the examples where this is a violation, and I will find similar violations. All right, and last but not least, on the dimension of quality attribute is the idea of AI for accessibility testing. And, you know, this is pretty cool work as well, where Keith Briggs, from the Ultimate Chronos Group, also picked up an open source prototype, the agent prototype that Diani did for his work, and extended it for accessibility, right? So a lot of tools like Lighthouse and Axe have provisions for accessibility, but what's the pain with a lot of those tools? Well, a lot of pain is that you have to spin up the application first and go to every single page and kind of do that. If your accessibility tool doesn't support certain types of authentication, then you gotta use Selenium on one side or something else and go do this. Well, you know what? The bots have that covered because the bots are exploring the application anyway. That was the first step that we saw in our process, where the bots need to explore. And so you take that and combine it with these tools, and all of a sudden you have site-wide accessibility testing using AI. And there's a picture of the model that Keith and his team built for their application, and you can kind of scale down and drill in. And as the bots visit each of these different pages that you see represented by these circles, it finds accessibility issues and produces reports of the different issues according to the WCAG guidelines, right? The WCAG standard for accessibility, right? And so that's pretty exciting to see happen on that scale, because again, one of the coolest things about this superpower is that it's needed because testers never get to check all these things, and they're always coming in as something else that we need to add on to the testing that we already can't finish, right? All right, so then problem domain. We're going to drill into some very specific areas of AI for software testing, and then we're going to wrap it up. But video streaming, also another area where you can think, well, this is pretty challenging for us to do, because how do we do it today? Well, it's not very automated today. It's a manual process where we have humans sit down and watch videos, right? This is the technical exercise, right? They sit down and they watch videos and rate them, right? And they produce this mean opinion score, very technical thing, which is just the average of the ratings from the humans. And I'm laughing, but this is painful. This is a very painful way to do testing. But humans are good at watching these things, right? And seeing and spotting issues. And we look at certain things and we're able to capture them. But after some time, even a human being may be zoning out and really not catch. And so you might get some inaccuracies there. But clearly this is slow. Clearly this is expensive and does not scale. And even though you might be saying, well, there's automation for video testing. Yeah, there's usually this frame by frame, pixel by pixel automation. And it's also very painful because the general approach is to comb through these videos and try to look for these different failure modes, right? Blank screen stuff, or drop frames and distortions or glitches, or lines. And we can do that, but how does that map back to the user experience, right? Like, what happens when you have multiple failures at one time? Is this worse for one user, or is it same? Does it matter where these things occur as well? Maybe if it's in a major scene that you were watching and excited for, and a glitch happens, it matters, but maybe it doesn't if it happens in another part of the screen. And so, yeah, how do you find the bug in this video haystack, right? It's hard. So AI to the rescue. AI can thrive on a problem like this because you can train the bots on the common failure modes, right? So they can recognize the common failure modes, but they're not gonna do it frame by frame, pixel by pixel. They're gonna do it with vision, just like what we're doing as human beings. And they can use things like the category of video as a feature in their model, because live action versus slow scenes versus animation, it's all different. So that can be a feature. And last but not least, they can also have the focus areas and focus on the areas that humans would. And then what we can then do is, given that we have some data that humans who've watched these things and watched different categories and had mean opinion scores, we can take that information, train the neural network with those examples, and then we can teach the bots to predict the mean opinion score. And I wish that this was a mock-up, but this is the actual graph from training that we did back at headquarters, where we took some videos in the Asian fusion category and trained a model and was able to get, I look at this and you see the true scores versus the predicted scores of the bots. And that is the definition of a superpower. At that point, if I have a model that looks like that trends so accurately with what the human would judge, I am just as good as having a human being there for this particular problem. So the bots are simulating this human judgment and doing so incredibly, right? So all pretty cool, but doesn't solve the end all be all. But you know what? You combine AI with some commodity hardware like a Raspberry Pi, and all of a sudden you got a stack where you can test all sorts of things. Because remember, anything with a screen. So if I grab the HDMI, if I can send signals, then I can emulate things like Roku or the Fire Stick. We've done all of this with AI to be able to stream and validate those streams on different platforms. So now AI helping you across compatibility testing, right, as another dimension of this, which happens to be another non-functional requirement. All right. And my favorite, which is where most of my time these days has been, my daughters come into my room and in the office here, and they ask me, "Daddy, are you playing games?" And I'm like, no, I'm not playing games. I'm working. And it's hard to convince them of that because a lot of my presentations having characters from very popular and famous video games. So just bear that in mind. But, AI has been playing games for a very long time. And it only makes sense that we would get here now and be able to test them. But when you think about traditional approaches, there's very heavily manual effort again. I'm seeing AI now creeping up and taking over spaces where things were very, very manual, very, very rigid, and still are. Like we pay hundreds of people to sit down and not play video games, because playing video games is fun. Testing them is not so fun, right? It gets repetitive, and it's not the smiley, fun stuff that you think it might be. And so the other part about this is that in addition to being very manual, it's just not very representative of the user experience in many cases. If you do have any automation, sometimes it's in a development environment that's kind of bare bones and you're spinning up these things and it's not realistic. It's not something that's able to, because you kind of need to be in that environment, but you don't have everything there because you want to test just a couple things. But with AI, you can look at the entire image as the customer would see it and find issues in that way. And most of the important bugs are with the rendering side of things. It's not with the game logic, where there are testing frameworks like the Unity testing framework and stuff like that, doing unit testing at that level. But that's just the game logic. What about the rendering and those kind of visual bugs? And so that's where this shines. So there's a lot of different dimensions of game testing, right? The core functionality of the application itself. There's the game stores, which is a direct source of revenue for a lot of these major companies. There's visual and audio testing that needs to be done, as well as testing the gameplay. So you can think about it that, all of these different pieces need to be addressed, and AI is actually very good at testing these things. So let's talk about the functional testing side of things, right? So we can, again, use computer vision, detect elements, and then we can build tests that walk through the application. And that's cool. And this is an example of us building a test for Battle Breakers and running that test. And the test actually walks through the gaming application, gets into the gameplay, and then interacts with the game elements in the game. And so that's like a fully functional like smoke test, if you ever had one. New build comes out, let's crawl through the application, get into gameplay, and now we can do further testing, right? Direct application to something that has tangible benefit to a gaming company. But beyond that, because you're using computer vision, now you get into doing things like saying, oh, you know what? I can tell, because I can build a classifier for that character, right? I can tell that this is Maverick. I can also train another classifier to render and recognize his backpack, or this backpack, not his backpack, but this backpack on a character. And remember, these are not just static images I'm talking about now, right? I'm talking about actually spitting up this character, taking a video, rotating him or her at all angles, or the asset, the backpack, and then extracting all of the frames from this to be able to take all the snapshots from different angles and training the bot to recognize these characters and these items and these assets at any angle under different lighting conditions, right? And so now you can think, oh, I already have the ability to crawl through the game, and I can select certain options, and then now I can have a classifier that recognizes, oh, I have Maverick there. Does he have the backpack? Yes, he has on the backpack. And so now you have a fully functional test. It's not just a smoke test now that just gets in there. You have a fully functional test to test the actual application and the different things that a human can do, and then verify that it looks the same visually, right? And that it is what you think it should be. And we take that a step further with AI, because AI is very good. The computer vision is very good at being able to say, okay, you know what? There's not just a difference, but here's exactly where the difference is, right? So we can have a baseline observation that humans validate and say, like, yep, this is what it should look like. And if that changes, I want you to tell me about it. And if it changes in a way that I don't care about, like, I can ignore it. But if it changes in a way that I do care about, I can flag it as a bug. And all of a sudden, that feedback mechanism starts the bots to be able to find bugs and glitches in games, in visual assets of games. And then not only that, then we can take this mask, right? Let's say that these were glitches on other parts, and we can overlay it so that people can see exactly where the visual glitch is occurring and take it back to an animator and say, hey, this is a problem. It's not just visuals, there's audio, and guess what? AI good at that too, right? Taking some baseline audio file, instead of thinking about visual differences or audio differences, you can check, does the audio flow through, right, and correlate to this other audio file, right? So if you have a sound effect that you want to make sure still sounds the same, you can gather the baseline observation, gather the test observation, and then you can say, well, accounting for any differences in time and amplitude, if one signal sweeps through the other signal, then I have a good cross correlation and I know that that is good. If not, then I can throw up my hands and say something is wonky with the sound effect here, something went wrong. And so there's just so many applications of this, but perhaps the coolest thing to see is the bots actually testing the games from end to end. We just had a cool weekend where we kind of did this hackathon, running through some games to kind of take our infrastructure and our frameworks to another level, playing games and testing them in real time and gathering that feedback, detecting objects. And so here's our bots playing Call of Duty. So pretty awesome. And how this works is that we tie in the reinforcement learning, right? And we combine that with the object detection and those things together, right? So first we train the bots to recognize enemies or friendlies or guns, and there's the active weapon or there's the health. And then we give it goals. We said, okay, here's the actions you can take. You can move forward, backward, you can shoot. But I want you to pay attention to the kill count, right? That's your score, right? Make sure that that kill count, you want to give the bots rewards when that kill count gets higher, right? And higher and higher and higher. Or you can grab a screenshot of the health bar and do some calculations, say, well, your health points, I don't want this to decrease. So, you give it a negative reward if it decreases health. Or we can teach it to aim, right? We can say like, usually most games has a visual cue when you have the enemy in your crosshair. The crosshair changes from white to maybe red. And so we can train the bots and give it rewards for that behavior. And all of a sudden our bots are just playing Call of Duty. I mean, it's pretty cool to watch, I can say. It's not trivial. It takes a lot of work to train, but once it's done and you watch it, it's almost like magic in a way. So just want to start to wrap up, and then we can open up for questions with the fact that every year since I've been in Romania, I've shown this slide. I didn't have this slide in Romania when I first was there because there weren't that many companies. There were probably like 2 companies at the time working in this space. But these are all folks that are pursuing, different aspects of this dream of leveraging AI for software testing. And this is actually probably needs updating again as this list just keeps growing, I feel like, every minute. But you can see that there's this rapid explosion of different companies and folks leveraging AI for testing. And it's cool because we're seeing like the future of software testing start to happen now, because we're seeing AI being used to address core testing concerns, right? At the UI level, the service level, and the unit level. And then we're seeing AI being used to address cross-cutting concerns, right? Usability, performance. I didn't even talk about security, but that's a whole topic in itself, but you can do all these types of testing with AI. And that's all cool and great. And I think we'll eventually see a full stack takeover of AI for testing. But where I get very excited and passionate about is the fact that we have a lot of AI systems already out there, a lot of narrow intelligence happening, and some of these systems learn at runtime. I just did a course for O'Reilly on testing ML systems, right? My first online training course with O'Reilly and media, and it was all about this. And one of the key things that I stress to people is that AI is going to continue to evolve and learn after you deploy it. And so testing needs to be a continuous thing after deployment as well, not just pre-deployment, but after deployment, and machine learning operations and all these things. And so it was good to kind of go through that and share that with mainly a cross section of folks from different disciplines, right? Software engineers, software developers. I had business analysts in there. I had ops guys. I had performance testers in that class. About 90-something people going through that course on testing ML systems, because there's a great, really not just testing, but quality engineering for machine learning and AI and machine learning systems. The future is now, and I think we're going to need to use AI to help test AI and build these systems in a way that they can be trusted, because testing is an integral part of it. So I leave you guys with that nugget to say our future in software is not shift left or shift right. It's actually shift inwards to be part of the system design where testing probably should be. So, and that's it. Thank you. Feel free to connect on LinkedIn or send me an email or Twitter. And I think I gave you enough time for having engagement and questions. So I tried to power through that. So awesome.
Okay, Tariq. So someone from the audience is wondering, how do bots cope with minor changes, like adding an extra field in a screen change model of an API parameter, or more exactly, what do you have to do as the owner of these scenarios?
Yeah, that's a very good question. So there's some good news there. Where is that? Let's say, for example, you add a new field. That's not really a big deal at all, right? But even if you added a new field to a Selenium script, it wouldn't be a big deal, except that you have to model that and that you have to add and change your tests, right? The bigger thing becomes what happens when you change something in a way that it could be a breaking change, right? Because the additive change is usually not necessarily a breaking change, except things like if you add a page to a flow, and you didn't have that page before, and now you break navigation steps and stuff like that, right? But let's say you were to remove, or change or modify something, move it around, change the styling. The good thing by using computer vision, number one, is that because you're not tied to the DOM, right? Like we're a Selenium script, for example. I'll start with the UI level and then talk about the API stuff. Like if you're doing something at the level of Selenium and you're using the DOM, the minute that you change that in a way where the ID or the structure of the DOM changes, now you got to go fix something. Either you got to fix your page objects, or if you did a really bad job, you got to go fix a million tests that touch that, right? But either way, you got to go fix something. The bots, they don't care necessarily that you change the structure of the DOM. They're not looking at that. They're just looking at it visually. And even when you change it visually, because it's been trained on so many different examples of, like, for example, a shopping cart or different kinds of buttons or different kinds of pages, even when you change things visually, the bots don't break. So that's one benefit there in terms of that. And the big testament to that is for video games. Like we've had some of our gaming clients actually redesign their game. And our software, our bots, they deal with that change like a champ, which is the main reason and motivation for them trying to find a solution that uses AI, so that they didn't have to worry about all that breakage, right? The other part about this at the UI level, which is important, is that piece that I mentioned about navigation, right? Because normally, again, if you change the navigation flow, if you add a step or remove a step for anything, you got to go change some Selenium script or something somewhere to address that. But the bots, remember, they use reinforcement learning. So if it tries to go down a path that it, is a custom going down and it can't get there, it's goal-based. So it says the goal is to get to the checkout page, right? And it finds another way. It does trial and error and finds another way to try to get to the checkout page, right? So that's kind of how that works at that level. At the lower levels, when it comes to API and other things, when it comes to dealing with changes, it really depends. If your change and adding a field is done in a way where, you have a new field, but it kind of is something that is familiar, right? Like maybe it's another quantity, another price or something, something that it recognizes, the bots can still deal with that and generate new tests on some of those same things, and some things can be reused. Other times, it doesn't give you much benefit, but it doesn't break, right? It doesn't break, which is, I think, we struggle with test maintenance, and so just think of the benefit that way. So it's not that it'll do everything for you, but at least it doesn't break. So hope that helps.
Okay, I'll go next. But first, I wanted to say that it was really insightful to see your presentation, and the fact that you gave a lot of examples from a lot of fields. That was really cool, in my opinion. My question is, and it's a question from the chat: will AI testing ever replace traditional testing, or do they go hand in hand?
Well, tradition. It depends on what's meant there by traditional testing. So I'll answer that in two ways. I'll assume that traditional testing could mean two things. The first thing that I think it could mean is the traditional way of doing automation today, the Seleniums and that stuff. I definitely feel that it can replace that, and that it can go hand in hand with, right? Because we have even personally released an AI classifier that is integrated into Appium, right? And Appium is, there's other things that you'll see on that front, but we can, and we're working on some other stuff. It's probably more top secret than I can share, but we see that integrating with existing frameworks is a way to go, right? Because people have invested in all these frameworks already. So you don't want to tell people, well, throw away all of your tests, right? But then if we can make them better by improving them with AI, I think that that's definitely a path that we can go. So from that sense, I see both things. It can replace some things, and it can definitely enhance some things. The other thing that I'll say in terms of traditional testing, right, or traditional testing, is I think some people equate that with, is AI going to take my job away, right? Like, I'm a human being, I'm a manual tester, I'm whatever you want to call yourself, or is it going to take my job away? And I'll say this, people thought back in the day that when an automated telling machine, an ATM, was made, that it would replace all people in the bank. And even when they put those things in the actual physical banks, they thought, okay, there's no more bankers, right? We still have bankers today. You still have tellers today. I used to be a teller. That was my first job out of college. Because you still have people, right? And people don't always want, sometimes people want to deal with machines, and other times people want to deal with people, right? And that's the fact of the matter is. So what technology does is it can replace certain functions that might be mechanical. It doesn't replace human beings. So if your only job is to do something very mechanical, then I would suggest that that's not a good job anyway. So try to find something different that you want to do. But most folks in software, there's so much other things that they could be doing that they just can't get all the time to do, that the machines, getting smarter and being able to take on some of those tasks that we couldn't before, which is why you see GitHub Copilot, right? This is why you see all these areas of not just software testing, but software engineering. And you see the bots are here, and I think that they're here to stay. So I don't think it'll replace that. And then also remember, there's a big mapping between software testing and machine learning, because machine learning is all about examples, inputs, outputs, simulating a function. Testers do that all day long. So I think that even as that, from that perspective, the testers are the ones that are going to be training the machines quite a bit, because the testers know how to deal with data in droves. They know how to think of edge cases. They know there's a whole career there waiting, which is why I created this course on quality engineering for machine learning, because I think that it is it's time to shape that whole community to recognize that they're needed if AI is going to be successful. So hopefully that answers the question in multiple ways. Whichever way you meant traditional testing, I think I got it covered.
Thank you, Tariq. Firstly, I will remind everyone that we have a feedback form in the chat, and maybe you can help us improve this session in the future. I will go on with the questions from the audience. We have another one about how do we handle false positives or negatives?
Okay, cool. Yeah, there's a couple ways to handle false positives or false negatives. One way is get better data. That's the first one. Get better data, get more examples, and continue training. That's one thing. The other way is tuning. So I just, again, in teaching that course, one of the things that I talk about is the fact that there's always a trade-off, right? For example, between for a given problem, we tend to use AI to predict probability. So let's say you have a problem where your AI is trying to determine, what are a given photo that might be a big cat, right? So like a leopard, a jaguar. People confuse these things all the time because they're similar, right? And what you would get the AI to do in that case, instead of just telling you, is this a tiger? You want it to tell you, well, what is the probability that it's any of these things? And you get back those probabilities, and what the AI is going to do is it's going to say, well, okay, let's say a trivial example. If it is at least a 0.5 or higher, then I'm going to say that it is this animal, right? But let's say you look at your results and you start to see, like, look, it's making a mistake a lot on this particular type of animal, and maybe I just need to change that threshold from 0.5 to something else. So there's different mechanisms for you to look at your results from an AI perspective and tweak your thresholds, improve things like the false predictions, right? False negatives and false positives in that manner. So there's things like the precision recall curve. There's the receiver operating characteristic curve. And so there's all these different little mechanisms for tuning. And so if you're talking about that kind of stuff, then you're digging into the ML world, and those are some diagnostic tools that you can use to help with that problem. That was a good question, by the way. That's a very good question.
So thanks for your answer. I do have one more question from our audience. If I want to implement a solution using AI or ML for software testing, what technologies should I use, or what should I know? And if I am to extend a bit the question, how would the roadmap for this look like?
Yeah, that's also a very good question. It gets asked a lot. A couple of things. The first thing I would say, if you just want to learn about AI, that's fine. There's many avenues to learn. If you seriously want to do something that's meaningful for your company or for yourself, then you start with the problem, right? You don't put the you don't put the solution in front of the problem. You still start with a well-defined problem, and you do some research on that problem to see if AI is even a good solution for that. Because there might be a more AI solutions tend to be more complex. They require a lot more, and so you don't want to necessarily, if there's a good efficient solution, go down the AI path. Again, if it's for learning purposes, then do whatever you want. It doesn't matter. But if you're seriously trying to do this from a business standpoint to bring value to the company, find a problem where there's some area that you think AI could really make a difference because you're struggling with something, right? Now, in terms of tools and technologies and places to start from that standpoint, you can't go wrong with starting with Python. I mean, almost every library that you can look at out there and all these things is all in Python. Like most of the course that I teach on, AI for testing is all Python code. It doesn't mean that Python is the only thing. Like the real super nerdy data science people will tell you learn R, right? Because all the neural algorithms come out in R. So if you want to be popular and cool and edgy, like learn both Python and R. But there's also a number of places where you can get started. I found very useful. There's a website called machinelearningmastery.com. I can always send it afterwards, but machinelearningmastery.com, a gentleman by the name of Jason Brownlee, he always has topics on ML and practical code examples. Like it's all like just very practical, hands-on machine learning. And so I love that for sure. There's a couple of courses from Andrew Ng and Lex Friedman on YouTube, still there, from Andrew Ng's Stanford course, and then Lex Friedman had a course on self-driving cars. They're free. I watched them when I was first starting off. Probably when I left Yash, I probably went and watched them right after that, and got up to speed on some of these things. So your roadmap should be just one that is again, aligned with your business, right, and what you're trying to achieve, and take it in pockets, right? I think when I look at applying AI and machine learning, especially for the first time in an organization, start with a smaller project that is kind of a fringe project that there's less risk, right? Because what people tend to do is to underestimate how much resources, how much time, how much design, how much effort it is for managing data. And if you don't understand that yet, you want to get a feel for it on something where there's not a lot of risk there. So I hope that helps with the positioning there. And feel free to reach out to me, and if you have any more thoughts on those things, I'm happy to help.
Thank you, Tariq, for answering this question. We have some more in the chat, so people are interested in this subject. The next one will sound like this. How good are the bots in generating test cases from requirements? Are there any limitations in that?
Oh yeah, there's a lot of limitations in that. So yeah, I actually did some work on this firsthand, which is good while I was at Ultimate Software. So we had a project where we were parsing through user stories from Jira, which is our system of record, and we were trying to use natural language processing to interpret and pick up certain aspects, right? So analyze the verbs and the nouns and do some stuff there. And we were able to train a decent classifier to start to understand the requirement, right? And when I say understand, pick out certain things and then map them to domain items so that we could do certain checks, so that we had something else to go with for the bot. So the bots didn't just like click here, click there, and click there, and then then we could check something, right? So that was my first view of requirements in that sense. The other thing that I've come to realize, so the bots aren't that great at that. That needs more work for sure. There's a PhD student right now that I'm on her dissertation committee. She's from FIU. At my alma mater, I did my PhD at FIU, and her advisor is my former advisor for my PhD. So I'm on her committee, and she's doing model-to-model transformations from requirements to testing, right? So she's transforming requirements into test models and having a formal model. And I know that the output of her work will be very useful for making the bots better, because if you have a formal model, then you can use it for test generation, right? And she's already doing transformations from requirements. So that's going to be exciting. But it's lacking and it's hard because you're talking about natural language, which is ambiguous for many languages, and English, for example, is even worse when it comes to ambiguity. But the other thing that I realized on testing from requirements is that this whole idea of reinforcement learning and using goals as a driver, that those goals are in form of requirements. And so reinforcement learning in itself, right, when the bot learns to play a game, you're giving it requirements. And I learned to treat that as a form of requirement specification. Can I train the bots to do the things that I want them to do? If I'm doing validation, then those things are good things, right? And getting to goals, checking out items from the cart and making sure that those goals are satisfied. If I'm doing negative testing, then those goals are bad things, right? And so from that standpoint, I look at reinforcement learning as an optimization problem where the bots are getting better and trending towards some goal or requirement that you have. And so my view on that is kind of, do I need a formal requirement, or do I just need a really good set of goals? And testing is about goals, right? And setting testing criteria. So hope that helps answer that question. Man, you guys have really great questions. Sorry, this is serious.
So you just mentioned reinforcement learning, and we do have a question related to that. And okay, it's also related to any open source solutions that may be. So do you know of any open source solution that has AI in it, which also covers reinforcement learning?
Yeah, OpenAI has the OpenAI Gym. We use that all the time. So I encourage you to look at OpenAI Gym for that. I'm sure you can find Q-learning algorithms out there and examples of using Q-learning, so it shouldn't be really hard. I can send that. OpenAI Gym, GYM is the name of it. But we use that a lot. It's a modeling environment, allows you to set up reinforcement learning. We use it for games and other things, but it can be used for almost any problem.
Okay, thank you, Tariq. The questions keep coming, so I'm gonna go with the next one. Someone from the audience is wondering if AI testing has learned or used anything from a quick check, so basically property-based testing.
Wow, yeah, good question. It's a good thing that I have a PhD that focused on software testing. Otherwise, I wouldn't be able to answer some of these questions. Yeah, so there's actually a lot. I was just actually talking with one of my colleagues, Iani, about it the other day, because we were doing the AI for game testing, and we were saying, oh, you know what? Like, if we could use like OCL and set constraints and invariants and stuff, then that would help us with our test generation and our ability to know if the bot is running into things or properties that it shouldn't run into, right? And it just reminds me of my days of software specification and, you know, learning LTL and CTL plus or star, CTL star. I used to teach these things in college. I think that there's a big opportunity for different model checking, and by model checking I mean formal specification techniques like properties and that sort of stuff to be leveraged for AI. I'm sure that there's people working on them. We just haven't done a lot of it yet. But it's not, I'm telling a little bit of a fib. We did publish a paper that used some formal constraints for form testing that we published in AIST a few years back. I can send that paper where we do use properties on that stuff. It's just that I didn't work on that part, even though I'm on the paper. I just had to read that part. But I think that there's probably more people doing more of that stuff, but it's definitely an area that we can expand on. So if you have a background in that, I think that that's an interesting bridge for sure.
Thanks for your answer. Another one from the chat. Can bots choose what test cases should be automated later on? So set a priority for them. Yeah,
for sure. Yeah, I mean, anything that you can do from a configuration standpoint with any test harness, you can have the bots do. You can even train the bots in different ways. Like the bots can do specific tests. They don't have to generate tests automatically. You can train them to do specific flows and have them do those. You can set that up in a CI and all those things that you could normally do. Like nothing precludes us from using the techniques that we have today and only going with AI first or driven approach. You can still use predefined tests and not use test generation. In fact, we have a scripting, you'll see it, many people do. There's a scripting support for the bots. And then there's an autonomous mode for the bots, right? So yeah, you can definitely mix and match those as you see fit. You can set priorities, you can select tags to run certain groups of tests together with the bots. You can do all that stuff.
Okay, thank you, Tariq. The questions keep coming. The next one, it's more for an organization level. What would be a good starting point for an organization which is not using AI testing at the moment, and they want to start with it?
Yeah, that I get that a lot. I would say first, define maybe some criteria for, again, I always encourage people to start with the problem, right? And the major problem is that usually there's areas of testing, and as the person who was the head of a quality organization for years, I saw this a lot. As business leaders, we're always thinking about costs. And a major part of costs for testing has to do with the maintenance issue. So you've seen that a lot where people are spending time cleaning up CIs or debugging failed or flaky tests, and they're doing all that. But you have a big investment as well in some of the automation that's there. So some of my advice is, first of all, don't be afraid to try something new and to not, sometimes as testers and a testing community, we want to hold on to every single test case, right? And we run all these, even though half of them are flaky or whatever, we don't want to throw it away, right? Because we don't want to, what if that test is the one that we failed to run and there's a bug there, right? We get into that. And we don't realize that the amount of time and energy and cycles that we're spending to keep that test is actually not worth the benefit of that test. So I would say, don't be afraid to change something in a particular area. Of course, you want to be risk-based. So I would find a team that is, number one, either maybe a new team that's spinning up, doing something new for the first time, building a new feature, or maybe you're going to build a new product or platform, and you want to see if AI can start to help you there, because you have no test for that stuff already. So might as well let the bot see if they can be used for that, and then go to adopt from there. So I would find some pockets of projects like that and use that as my test bed, because the risk is lower and the gain is quite frankly higher, right? Because you can go from, one of the big benefits of using AI for testing is that, like, in 5 minutes, like I can build a set of tests for any app. And usually if we walk into sales calls, we already have whoever reached out to us, we already have their app automated and we have test cases for it. And sometimes there's like, wow, we don't even have that many tests for our stuff yet, right? So think about, vanilla projects like that you can say, hey, or a team that is just tired of dealing with all you gotta zip it up and throw it away. I had my teams back at Ultimate clean up all of their CIs, and first thing I said is that any kind of flaky tests that you have, quarantine them. I don't want them there anymore. Remove them. But as a leader, I had to be able to say that and have the teams understand that it's gonna be okay. Those aren't providing you as much value as you think, right? Because a test that says yes today and says no tomorrow, when nothing has changed, is not valuable.
Thanks for that. Another one from the chat. Are you able to tap into the knowledge gathered by large companies that work with big data in order to use that data for training your AI? The question is somehow oriented towards game testing.
So, we can work with any large company if the right non-disclosure agreement has been signed. So we have been working with large companies, but large companies are still very particular about their data. Obviously, data is an issue, but yeah, like I think data in this space is kind of like king or queen, right? Like you have to be able to also know how to manage and how to maintain it, and otherwise your data project will rule you. But yeah, we have, I think, the ability to do that is key, and having that data is paramount. So the fact that it's there is the first thing. Is every large business willing to kind of do that with their data? In some cases, yes, and in some cases, not all the time. In the context of gaming, it's usually not a huge barrier that I've seen on the data side. Folks are pretty willing to share and allow us to do what we're doing, within reason, right? Still got privacy and all sorts of other issues to think about, but yeah. Hopefully I answered that question.
Okay, thank you. I have another interesting question. Someone is asking, what loss function should we use when we are training the data for games like Call of Duty, for example?
What loss function should you use? Is that the question?
Yeah, what loss function should we use?
So that's I would say that you have to model your problem and build your solution and tune your model and keep going, right? I wish I could say that it was, for example, Call of Duty, that we just, even for playing Call of Duty, like I'm sure that we could always improve our models. So there's no There's no one cookie cutter answer for that at all that I would ever dare to give. This weekend, we just trained on a particular set of games, and we were doing a lot of trial and error to try to see how if we could improve and converge better. You got to worry about things like overfitting and things like that. So there's no one magic formula. Maybe there's patterns that you can learn over time. I certainly haven't learned, any kind of magic formula for some of these games, but I think by now maybe some of my team members are probably getting closer to being able to figure out, given a particular game or class of game, a runner, a shooter, or whatever, how to model it that they can get good results. But I can't just certainly spit out any concrete answer for you right now. But I'm sure they're also happy to talk to you if you want to reach out. So you can see that I love talking about this stuff no matter what, and maybe I'll get in trouble, but I don't get in trouble very much.
Yeah, thanks for your answer. I think we have one more question, so this is the last one. And we did talk about generating test cases, but can we also generate some data in order to run those test cases?
Yeah, that's this had to come up, right? It always comes up because we talk about data and training data, but test data is a big part of being able to adequately test anything. And so, yes, test data generation is a huge piece of it. Actually, my CTO buddy and Jason Arbin, he started something called opentestdata.org to kind of help with this, because like if you think about data, different organizations have different are kind of like the best representatives for data, right? Like, UPS or FedEx have like the best addresses, right? Like those is the kind of thing that happens. I think it would be good to be able to have more automatic generation of testing data for testing, right? So test data. But it's a hard problem that's still not being fully solved. Some of like Diani's generation techniques are to make constraints that really query then a data pool and bring you back data that fits some language. So you had to create a language specification to do that. So if I need a first name or last name or whatever, you can query. So that's how the bots are doing a lot of that these days, is by mapping to some of those known domain models, right? But yeah, still opportunity to do better on test data generation. Cool.
Thank you very much, Tariq, for answering all the questions. We are very happy that we had you tonight. Everything you shared was really insightful and has made us curious to learn more and read more about the subject. I will remind the audience that we need a little bit of feedback from you to know how to improve the next sections. And that being said, I think we can all have dinner.
Well,
thank
for
you very
some of
much.
us, dinner is lunch, right?
Thank you very much, guys, for being here, and see you next time.
Thanks, folks. Thanks a lot.
Thanks. Have a nice evening.
Bye, guys.
Bye-bye.